Today I'll be proving the area of a parallelogram in a different method than I did in the last video. So without further ado, let's just arbitrarily main this vector AC. So this would have position A, C. And then let's make this BD. And then the parallelogram would look like here. Oh, sorry, this is a bad parallelogram. I'll redraw it. Oh, my bad. Hopefully that's better. All right. Okay. So we want to say that det A equals area. So first and foremost, what is area? Well, area is, let's denote base as B1 and height as H1. So area equals base times height for a parallelogram, all right? So let's look at this. Its height would be from here to here, and this would be a right angle. So this would be H1, right? And what would B1 be? B1 would be this length right here, B1. That would be B1. From here to here is B1, okay? So we know what B1 is. B1 is Pythagorean theorem, just a squared plus c squared root, right? By Pythagorean theorem. Because this is c, this is a, so a squared. So B1 would equal root a squared plus c squared, all right? And the trickier part is height. Now we need to do a projection. So we need to project this vector here onto that vector. And that's the same as projecting this vector here onto, well, this vector. All right, so let's do the projection. So basically, it's a projection of BD onto AC. So if you remember your projection formula, proj, let's just name the projection of BD onto AC proj would equal the dot product of AC dot AC. Wait, let me think. Hold on, no, I did something wrong. Sorry about that. Alright, never mind, I didn't do anything wrong. So H1 would not equal projection, but I'll show you what H1 equals. So the length of this by Pythagorean theorem is b squared plus d squared. Okay, so b squared plus d squared would equal proj squared plus h1 squared. Hopefully you know where I'm getting this, because let's look at this triangle here. The height of this triangle would be h1. It's a right triangle. Height would be h1. Its hypotenuse would be b squared plus d squared root. But we're going to do Pythagorean theorem regular. And this thing right here would be the projection of BD onto AC. So this is the equation. So this is the height, this is the base, which is also the projection of this onto that. And this is the hypotenuse, which is b squared plus d squared. All right, so let's continue on finding the projection. You should know your projection formula. It's this, BD dot AC times AC. But remember, we want to find the length of the projection formula. So what we're looking for is length of projection formula, and then we have to do this. All right? And this is basically just a dot product root. So let's do this. So on the bottom here, we get that a squared plus c squared, right? Dot product. And then we get AB plus DC times root a squared plus c squared, all right? And let's plug it back into that formula. So we know that, let's just isolate h. H1 equals root right? H1 equals root b squared plus d squared minus proj squared, which is this squared, which is something really big. I gotta write small here. This squared times a squared plus c squared. We take out the root. Squared root is just squared. So this is what h1 equals. Now let's begin with a new page. That means area, which equals b1 h1, must also equal, well, root ac squared. Oh no, I'm gonna run out of space. Shit. Sorry for the language. Times root a squared plus b squared minus. All right, and something you should notice here is this thing cancels out with the denominator of that. So let me see here. So this would cancel out with that. Okay, let me just do it step by step. Equals root a squared plus c squared times b squared plus d squared minus ab plus dc squared over a squared plus c squared, because this cancels out with the bottom here. And then this further cancels out with this. When we multiply a root by a root, we remove the root and put aside in this root. So we get this. All right, so let's expand this, which is just a squared b squared yeah, I'm running out of space, minus 2abdc. All right, and look, voila, a squared b squared cancels out, d squared c squared cancel out. We just get root a squared d squared plus c squared b squared minus 2abdc. And something you should notice here is that this just equals root, let me think, oh yeah, ad minus cb, right? Which just equals squared, which equals ad minus bc, right? And this is the determinant. So hopefully you know how I factored. And let me think. Yeah, so I factored this way, and I got ad minus bc, and this is the determinant, so det a. Hence det a equals area. So we know whatever we did right here is gets us the formula for area. And we now know that whatever we get here is also det a. So det a equals area. And this is the proof. Thank you.